Hi there, my name is Eldar Karlsson and I did the audio design and implementation of Rainbound, which released this summer of 2025 on Steam. Rainbound is a cinematic, story-driven 2D platformer where you play as a small bird named Puddles. The game is heavily inspired from the games like Ori and the Blind Forest and Sheepy: A Short Adventure. In this video, I'll be going through the features of the game, particularly some of the technical sound design choices and implementations. For this game, we used Unity Game Engine and FMod Studio as a choice of middleware. The game includes several cinematic sequences that play a big role in telling the story. To manage these scenes, we used Unity's timeline system, which gave us precise control over how animations, camera movements, and audio elements were synced. At first, we triggered all cinematic sound cues directly within FMod. Since I was the only team member familiar with FMod at the time, every change had to go through me. This quickly became a bottleneck, especially as the timing of the cinematics were frequently updated during development. To solve this, we moved the sound cue triggers from FMod into Unity's timeline by using timeline notifiers to call on FMod events. This allowed us to place audio directly on the timeline, removing the need for extra code or hard coding logic. It also made the system more modular and team-friendly. Anyone on the team now could adjust or add sounds without needing to open FMod. This sped up our workflow and made it easier to keep improving the cinematic experience as the project evolved. We use ambient zones to handle transitions between different environmental ambiences, snapshots, and music. When the player enters an ambient zone, the audio settings automatically change to reflect the new area. Once the player leaves, the settings revert back to what they were before. This helps to create a smooth transition as the player moves through the world. The challenge was managing these transitions in a way that was consistent across different scenes and easy for the whole team to work with. We needed a system that was flexible, reusable, and didn't rely on hard coding or manual setups for every scene. To solve this, we built an ambient zones as prefabs that reference scriptable objects. These objects store predefined audio settings that get triggered when a player enters or exits a zone. Scriptable objects made it easy to define ambience and music behaviors that could persist or transition smoothly between scenes. For example, when moving from the main menu to cinematic and then into gameplay. This setup gave us a reliable and modular way to manage ambient audio, and it was simple enough for the entire team to use without needing to touch any code. Since the player moves around constantly, and footsteps are one of the most frequently heard sounds, they needed to be accurate, responsive, and easy to maintain as new materials were added throughout development. The challenge was creating a system that could automatically detect the type of surface the player was stepping on. Implementing footstep sounds turned out to be a more complex task than I initially expected. In a 3D game, you can usually retrieve this information directly from the material of the surface. However, in a 2D game, the only thing you can interact with is a collider, which makes surface detection much trickier. To solve this, we built a system where each time the player takes a step, a function in the animation triggers a ray cost under the player. This ray cost checks which sprite asset is being used, reads the name of the asset, and uses that to determine the surface type. While working together with the graphics team, we managed to make the surface type to be listed at the end of each asset name, making it easy to extract and identify. Using that surface name, we set up a global parameter in FMod Studio called surface. This parameter drives not just the footstep sounds, but also jump and landing sounds. Expanding the system was simple. When a new surface type was added, we only needed to update the parameter and add a matching sound to it. This made the system both powerful and future-proof. I really appreciate you checking out this deep dive into the audio systems we built for Rainbound. See you next time.